All right, now for some fun with derivatives. So take a look at these two first of all. Notice that this one, the first tangent has an extra x. That means this one is the product rule, a tangent of x times a tangent of x. But this one is saying the tangent of x got substituted into tangent, so this one is going to be the chain rule. So for part A, the derivative will equal, the derivative of tangent is secant squared. And then what's inside the parentheses just stays there. And now do the chain rule. Now the derivative of this tangent is secant squared of x. That is part A. It can't be simplified. Just leave it like that. That one's done. For part B, we get to use the product rule. So take the derivative of each one, but only one at a time. So the derivative of this tangent is secant squared. And then leave the second tangent alone. Plus, leave the first tangent alone. And now take the derivative of this tangent, which is secant squared. And then this one can be simplified because this is saying secant squared times tangent plus another one that's exactly the same. That means that there's two of them that are secant squared times tangent. And part B is done. Then on to part C. The derivative of the e function is itself. Exactly the way it is. E to the tangent of x. And then do the chain rule, take the derivative of this tangent and multiply. Derivative of tangent is secant squared, so part C is finished. Then for part D, so this e to the x got substituted into the tangent function, so we'll be using the chain rule. So it's going to go take the derivative of tangent, which is secant squared, and whatever's in the parentheses just stays there. Now do the chain rule and take the derivative of this e to the x, which is e to the x. And this one cannot be simplified, so it's finished.